Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Fine. So, coming to the circuit elements that we did from the previous class, that is the active elements and the passive elements, or the active components or the passive components. Active elements or components are those which are the energy sources, means the voltage source or the current source, which gives us the supply of power or the flow of power in the circuit. And the passive elements are those which consume that energy, consumes that power, means dissipates that power, or stores or absorbs those power. So examples of active components are energy sources, like in DC it was battery or a cell. For AC it is transistors, diodes, triads, vacuum tubes, valves, many other things are there, which are the energy sources. These are examples which give us the supply of power. Those are called the active elements. And the passive elements, example, resistors, capacitors, inductors, transformers also. So, coming to the resistors, we talked about the property of resistance, that resistance resistance is that property of an electrical circuit which opposes the flow of electric current. Anything that opposes the flow of current, those are the passive elements, but resistance exclusively is completely dissipate, means it doesn't store any energy, it doesn't consume, it consumes to dissipate only. Nothing is left for storage in case of resistance. Entire thing is dissipated in the form of what? In the form of heat. So basically the property of an electric circuit opposing the flow of current at the same time causing electrical energy to be converted to heat energy is called resistance. Now resistance depends upon these four factors as we discussed: length of the material, cross sectional area, type of material, and temperature. And we all know R equals to rho L by A. I hope this is known to you. And we were talking about ideal voltage source. Okay, now coming to the voltage sources, I mean the energy sources. Energy sources are two types: voltage source and current source. And they can be further divided into ideal source and practical source. So ideal source was something which gives a, means in case of DC it gives a straight constant voltage throughout the whatever, you the current is drawn from it, irrespective of whatever the current is drawn, it gives the constant voltage. But practically it is not possible, because in all circuits there is, however, in case, always some very small amount of resistance present in it. So how is this flat constant voltage possible with any current you give? It is not possible, because there is nothing called no resistance present in a circuit. There is always something called resistance that is present in the circuit. So that small amount of resistance causes the graph to be like this. And that is why the ideal becomes the ideal case is a flat straight line constant, which is not the reality. In reality the practical is a slanted line. Why that is occurring? Due to the resistance it is occurring, because always small amount of resistance is present. Okay, so moving on to the main thing, voltage source we saw. Now this is the symbol of current source. You see an arrow. Previously voltage source is only represented by plus minus sign, means inside a circle on the top is a plus, and just below the plus sign there is minus. So plus minus is shown as plus by plus minus, voltage sign is source, voltage source is shown, and current source is shown in like this. Now, similarly, ideal current source is something which gives constant current at its terminals irrespective of the voltage appearing across its terminals. Means, whatever the voltage you are applying or it is appearing, you will get a constant current. Now, that is again not possible, because in any, just see the graph. Okay, in the graph, In the graph, VL is in the x-axis and IL is in the y-axis. So, in this VL-IL characteristics for the ideal source, IL is equals to IS. Means source current is equals to load current. Is is the source current source, is circle, that is is, and the one which is flowing to the load at the voltage terminals, you see at the load terminals the voltage is VL. So that is represented, the current is represented in the load as IL. So when IL is equals to IS, then only the graph for the ideal case comes as a constant, means a flat straight line. But practically every current source has high internal resistance which is in parallel with current source, and it is represented by RSH. Just see, in parallel it is represented. Okay, so that parallel representation of a certain resistance named as or represented as RSH. Okay, that parallel branch, because of that RSH, current through its terminals decreases slightly with increase at its terminals. Just see the graph here. For ideal case, it was a straight line, but practically due to the presence of ISH, that is due to the presence of RSH, the resistance, it is decreasing. So, as ISH increases, IL decreases. So, for ideal current source, just the last two lines you see, for ideal current source, RSH is equals to infinite, while for practical current source it is as high as possible. Previously in voltage source was what was the condition? This was the condition. For ideal voltage source, RSE is equals to 0 because it was in series. Here in current it is in parallel. But in the voltage source, RSE was in series. So ideal voltage source had RAC equals to 0 and practical voltage source is as small as possible. Okay. And in current source, we saw for ideal current source, RSH is equals to infinite. While for practical current source, it is as high as possible. This is very important because it can come in objective or viva voce or in the labs. It's demonstrated. So these things are the basic concepts. Whenever you will be asked about what do you mean by ideal current source, practical current source, and what are the values of R that you get in case of um, uh, ideal current source, practical current source, or ideal voltage source and practical voltage source. So this is the main criteria of the sources. Okay, so moving on to the next, which is actually a very important thing, that is called the Ohm's law. I hope you all have gone through in your PU plus 2 exams. Yes, Prerna, you have any question? No. Okay. So Ohm's law, coming to the Ohm's law, basically what does it represent or what does it give us? Why should we study that? Ohm's law basically gives the relationship between potential difference and current and the resistance of a DC circuit. Rather, I should not say only DC circuit because in AC circuit it becomes not R but it becomes Z, that is the impedance that we will go later. First, we should say that it gives the relationship between VI and R, that is potential difference, current, resistance. So what is the statement? Remember what the statement is exactly, that should not vary because it is a law. If you are writing it in exam or it comes in any test, then you should write exact the statement because it is a law, it cannot be changed. The words also cannot be or should not be changed. Okay, so Ohm's law, it states that the current flowing through the electric circuit is directly proportional to the potential difference across the circuit and inversely proportional to the resistance of the circuit, provided the temperature remains constant. So this is very important. This part, the last part, the temperature remains constant. If you do not state that, it is incomplete. It is not right. It will not be correct. So Ohm's law states that current flowing through the electric circuit is directly proportional to potential difference across the circuit and inversely proportional to the resistance of the circuit, provided the temperature remains constant. This is the exact law you should write. Mathematically, yes, it can be represented as I proportional to V divided by R, where I is the current flowing through, and that is given in amperes. Okay, the unit is in amperes. So I is the current flowing in amperes, V is the voltage applied, okay, capital R is the resistance of the conductor, and we give it as, or we write it as, considering everything as a unity, we write it as I equals to V by R, so that the unit of the potential difference is defined in such a way that the constant of proportionality is unity. Unity means 1 equals to 1. So we define it as in such a way that the proportionality constant, that should be any v by r, that should be that becomes equals to 1. So basically the expression becomes v equals to ir, and that means v by I equals to constant. That constant is R, the resistance, given in ohms. So it can also be defined as the ratio of potential difference between any 2 points of a conductor to the current flowing between them is constant, provided that the temperature of the conductor remains constant. So this is our main law. Remember, while you writing the law, you should write the expressions as well as this diagram, small schematic diagram that is shown. If you draw, it will be your additional. You'll get good marks. That's it. So this is a very very important law because in any kind of um, whether it is internal assessment IA, or if it is your finals, VTU finals, in all, this is definitely a compulsory question in every year. I'll share with you all the previous year question papers and all. You will get to see everything. Yes, Samiksha, you want to say something? Yeah, yeah, just mute yourself if not. So now I'll move on to, I hope, any question regarding Ohm's law? Till now, any questions? Anyone regarding Ohm's law? No. Okay. So I'll just move ahead. Mm, Ohm's law has certain limitations also, and the limitations also comes along with the statement in the exam when they ask you about the Ohm's law. Definitely, the limitations are also coming with it. So, limitations of Ohm's law: it is not applicable to non-linear devices like diodes, Zener diodes, voltage regulators, etc. So the electronics devices maximum operate non-linear wise, like uh, ni or ki to the power something, or means the equation is not a linear, either something in power it will be having, so those are the non-linear, or e to the power something logarithmic, those are non-linear equations. So the devices that operate on non-linear equations, in those the Ohm's law is not applicable. So obviously in the electronics devices like diodes, Zener diodes, voltage regulators, it is not applicable to these devices. This is the first limitation. Second limitation of Ohm's law says that it does not hold good for non-metallic conductors such as silicon carbide. So, such type of material also resistance depends upon. I just told you that the factors on which resistances depend upon that, on not only La means length, area, rho, temperature, all, not only these things, but also at the same time the type of material is also important. So that type of material, in case of, given an example like silicon carbide, so that type of material is not where it holds good, because those are non-metallic conductors but non-metallic. So, and also the silicon carbide, the law for such kind of non-metallic conductors, it is given by V equals to K I to the power mn. It actually, it is not shown. I to the power m is not shown. It equation is basically V equals to K into I to the power m, where K and m are constants. So for such laws, the voltage law becomes different for such materials. So this is about Ohm's law and the limitations of Ohm's law. Moving ahead, conductivity and conductance. This is again something which is important. So if you have pen and paper, I'll just request you to write down the formulas, because those are again important. Let me first define what is conductivity and conductance. Conductivity, see, basically, before starting, I'm just telling conductivity and conductance is just the opposite or reverse, or one by the inverse of resistivity and resistance. Okay, so if we know resistance and resistivity by now, right? So conductivity and conductance is very similar, just the inverse of that, resistance and resistivity. So, just coming to the definition, the specific resistance or resistivity rho of a material represent its opposition to the flow of electric current. Yes, resistance or resistivity is the opposition to the flow of current. However, reciprocal of rho means reciprocal of resistivity represents a unit describing the material in terms of its ease to allow the flow of electric current. That is known as conductivity of the material. So if rho was resistivity, remember R equals to rho L by A. So if rho is that resistivity, which is rho in the formula rho L by A, you get that rho. Inverse of that rho is conductivity. Okay, so this conductivity is equals to 1 by rho. Similarly, reciprocal of the resistance capital R is conductance G, capital G. That is, capital G is equals to 1 by capital R. That is inverse of, or 1 by of resistance. So here we go. The 1 by of resistance, we call it as conductance. So conductivity and conductance, as you can see, the unit of conductance or G is represented in Siemens. Okay, Siemens. So it will be better if you just write this down. And any questions regarding this, please ask. You see, G is equals to 1 by R. So unit of conductance being Siemens, we can say that G is basically equals to A. A is current. Okay. It is represented as A. It would be better if I wrote it as I. But anyway, R is equals to uh, V by I. Is it not, students?
Yes, ma'am.
Yes,
Yes,
R,
ma'am.
right. R is equals to V by.
Yes, ma'am.
Here, just the I is represented as A. Don't consider the A as something different. A is I only. Okay. So, because ampere it is given, that is why it is shown here like A. So, that is why if it is the inverse thing, then G is equals to A by V. That is I by V actually. Inverse of resistance. Now, R is equals to 1 by G, it becomes. That means it is equals to 1 by the sine of conductivity multiplied by L by A, because rho is equals to 1 by conductivity. Resistivity is equals to 1 by conductivity, right? So 1 by conductivity multiplied by L by A becomes our formula. So G is basically equals to this formula, gamma A by L. Anyone has any questions regarding this? Please ask if you do not understand any portion of this. I hope you are writing this down because problems can come. I'll eventually go to the problems part. So, is it okay? Everyone got it? Any questions regarding this? Okay. So, I am considering that you all are getting. If you are not getting, you can tell me afterwards, that is okay. But go through the entire thing, I'm saying, because otherwise you'll lag behind later. It will be a problem for you only. Okay. So, I'm going to the next part, which is formula wise again very important. It is the power, as you can see. Power. This much, the formula part written, everyone.
Yes,
Yes,
ma'am.
ma'am.
Okay. So, just moving on to the next part, which is the power. Power represented by P can be defined as the rate of change of energy slash work, energy or work with time. So, if you know energy means the unit or the amount of energy, the rate of that with respect to time is our power. So it is nothing much different difficult, because if energy is known, then the change of energy with time will also be known. So how is that calculated? The SI unit of power is watt or joule per second. Hence, capital P is equals to dWdt, that is the rate of change of work. Whenever there is rate of change of work, we represented it by differentiation, right? dWdt. So now I'm writing it as dWdt as I'm bringing charge. Remember the concept of charge. So I'm bringing it so that it becomes crisscross cancel wise, it becomes. So dW divided by dQ into dQ by dt. Now what is dQ by dt? It is current. So dW by dQ into current is basically becoming V into I, because dW by dQ, or the work done by charge, is actually voltage. If you differentiate charge, you see the explanation I have written down in the bracket portion below, that dW dQ is equals to V, because differential charge dQ, if given a differential energy dW, the rise in potential of the charge is dW dQ. Is this understandable by all or not? Anyone has any question regarding this, how this formula we came, that P equals to V into I? No. So I hope everyone got it. So remember this very, very important formula, because eventually this will be required for the problems. P is equals to V into I. Okay. Power is equals to voltage multiplied by current. Next, moving on to energy. Okay, so as power is equals to rate of change of work divided by time, or rather dw dt. P is equals to dw dt. Therefore, dw is equals to P into dt, power into time. So if we integrate that, we will get the work or the energy. Okay, because energy and work has the same unit. So I'm getting energy or work as the integration of Vi into dt. Energy is defined as the capacity of doing work, and unit is given by watt second. Okay. So just Vi is equals to P. We just noted that P equals to Vi. So in place of Vi, we can put P also. Okay. So W is basically equals to, or energy is basically equals to, integration of power into dt or integration of Vi dt. Understandable by all? Are you getting? These are the very basic things.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So, okay, thank you. So I'll proceed. As we noted that P is equals to V into I. So using Ohm's law, remember these two are the different things. P equals to VI is one formula, and Ohm's law V equals to IR is a different formula. So when you are getting these two, do not confuse, please. I have noted in the previous semester also, means just your division D division, I was there. Everyone confused these two formulas. Most of them, not everyone, they confuse. So do not just confuse that. One is V into I, another is V divided by I. Power is V multiplied by I. Resistance is V divided by I. Remember this very well. Power is the multiplication of voltage and current. Resistance is the ratio or the difference of voltage by current. Okay, so these two formulas are extremely important because we will be eventually applying these two only. Okay, so using Ohm's law, we get V equals to IR. Now I am putting this V equals to IR in the formula of power, that is P equals to VI. So P becomes equals to, in place of VI, just substitute IR. So P equals to IR into I. That means I square R. So this is another expression of power I am getting, or we are getting uh, two expressions of power. One is V into I, another is I square R. Both are in watts. So again, using the second version of Ohm's law, that is I is equals to V divided by R, we can again get another expression of power. Here we are putting in P equals to VI the value of I. So value of I from Ohm's law is V by R, V divided by R. So this I equals to V divided by R, I am putting in P equals to VI. So P is equals to V into, in place of I am putting V by R. So I get equals to V square divided by R in watts. Okay. So there is a note point, you see. It is to be noted that V is the voltage across resistance R and not the supply voltage. Remember this, that V is the voltage across the resistance R. Okay. So till this part, everyone clear? Three expressions of power. Remember, three expressions of power. One is P equals to VI, one is P equals to I square R, another is P equals to V square divided by R. Everyone clear? Any questions? Okay. So moving forward, I am going to the first problem of this module, or rather of this subject. I am going to the first problem. I think this is a very easy one. I'm not showing the entire thing. Just tell me the load resistance in a 220-volt circuit is 80 ohm. Determine the load current. Isn't it too easy? Anyone? Load resistance is 80 ohm and the voltage is 220 volt. So V equals to 220 volt. R equals to 80 ohm. So what will be I?
2.75 ampere.
2.7.
Right, right, correct. So it is
2.7.
simply correct, correct. In the upper formulae, it is written in the above that I equals to V by R. So definitely it is that. This is the easiest and the most means simple form. I am proceeding one by one. So using Ohm's law, I is equals to V by R. That is equals to 220 by 80 equals to 2.75 ampere. Easy and simple, nothing to worry. Now next problem. Determine the conductance of a short circuit on 120 volts which results in a short circuit of 500 ampere. So here they require conductance. Don't worry about short circuit or anything. Just see the values and what is the units. You will get the parameters. Okay. So first thing that they have required is conductance. Okay. They have given V, they have given I. Anyone who would like to try? Remember that?
4.166.
Okay, very good, very good, very good.
4.16.
Yes,
166.
yes. So G equals to I by V. Since I is given, V by given, V is also given. So G is easily found out. 500 by 120 equals to 4.16 Siemens. So till this part, very easy problems. Just revising the formulas, nothing else. So first part was about the Ohm's law. Second problem was about the conductance. Next, it is nothing to again very easy problem. Determine the power rating of a device rated at 15 ampere and 250 volts. So ampere means current is given, voltage is given. They have asked the power. So if V and I is given, so definitely apply V and I. P equals to VI, that is 250 into 15, 3750 watt. Okay, the fourth problem statement is not here. I'll eventually go. I think I should start this in the next class because otherwise you won't be able to understand. This is series circuit, means it will be a bit rush up that I do not want. I'll start it in the next class. For now, I'll just call the attendance. Okay. So attendance 46. Earlier it became to 48. Now it is 46. Anyway, I'll just call it. Am I audible?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Kindly respond. Okay, I am just calling. I hope you are everyone is familiar now with the roll number, class roll number. I am calling by that only. So 201. 201. Amrita.
Present, ma'am.
Okay. 202.
Present, ma'am.
Okay. 203.
Present, ma'am.
Okay. 204.
Present, ma'am.
205.
Present, ma'am.
206.
Yes, ma'am.
207. 207. Absent. Okay. 208. 208. 208. Santosh Badigar. Okay. 209.
Yes, ma'am.
Okay. 210. 210. Anil Kumar. Absent. 211. Ashish.
Yes, ma'am. 210 Anil Kumar.
Wherever you, I was calling. Anyway. So
No, ma'am. Here network is
211.
poor, ma'am. I went down.
211. 212.
Present, ma'am.
213. Rohit. 214.
Yes, ma'am.
215.
Present, ma'am.
216.
Present, ma'am.
217.
Present, ma'am.
18.
Yes, ma'am.
219.
Yes, ma'am.
Present, ma'am.
Who are you speaking? 18 or 19?
19, ma'am.
218 is present. 218. Anand Chogala is present or not? Okay. 220.
Present,
Chanda.
ma'am. Present,
Uh,
ma'am.
221.
Present, ma'am.
222.
Present, ma'am.
Okay. 223.
Yes, ma'am.
224.
Yes, ma'am.
225.
Present, ma'am.
226.
Present, ma'am.
226 is there, Karthik?
Present.
Okay. 227.
Yes, ma'am.
228. 228. Okay. 229.
Yes, ma'am.
230.
Yes, ma'am.
231. 231. 232.
Present, ma'am.
233.
Present, ma'am.
234. 234. 235.
Yes, ma'am.
236.
Present, ma'am.
237.
Present, ma'am.
238.
Yes, ma'am.
239.
Yes, ma'am.
240.
Yes, ma'am.
241.
Present, ma'am.
242.
Present, ma'am.
243.
Present, ma'am.
244.
Present, ma'am.
245.
Present, ma'am.
246.
Present, ma'am.
247, 247, 248,
Present, ma'am.
249, 249, 250,
Present, ma'am.
251, 251, 252,
Present, ma'am.
253, 253.
Present, ma'am.
Okay.
Present, ma'am. Present.
Okay. 254,
Yes, ma'am.
255, 255. Okay. So I think everyone has responded. Attendance is also done. So my class is over. Students, you can leave. I am also leaving. I'll provide you the recording. Thank you.